Okay, so 14 and 15, A equals, B equals, P equals, H equals, K equals. Okay, in this one, A is 1, B is 4, period is 2 pi over 4, which is pi over 2. Okay, and then let's go back. So pi over 2 is 2 boxes, according to my little ruler I made there. And H is 0 because there is a theta minus 0 there that we just don't write in the parentheses. And then K is 2. All right, starting with K being 2. And then A is 1. Okay, this is cosine. So the locator is H comma K plus A. Okay, and A are 2 and 1, so 0, 3, which makes sense because we start at the top with positive cosine. The period is pi over 2, which is 2 boxes. It's going to be a small guy here. And positive cosine looks like this. So I'm going to do the dot on the lower line first, and then the midline dots. Little tiny guy. He's cute. Somehow I draw them nicer when they're small, though. I don't know. I think that that is the last one of those that I'm going to do in front of you. Maybe in the review note? Nope. That's it. All right. Moving on to number 15. There's lots of these left. So 1 sigma, 2 sigmas. Now, this particular one is geometric, multiplying by 4. And if that is the case, then term 0 would also be 4. And I have to tell you, I don't love it when there's two things that are the same number in a problem, but it's fine. I can deal with it. Okay, so term 0, 1 is going to be term 0 times r to the n. And the term 1, 1 is going to be term 1 times r to the n minus 1. We're going to tell them to start at 1 because we're in math 3, and that's what we do in math 3. Just to say that isn't always the case, but for us it's going to be. And then 1, 2, 3, 4, 5. So we're going to tell them both to stop at 5. Okay, how are we doing on these? At least they don't take like 75 boxes, you know, and not as much writing as say chapter 8 polynomials. Okay, so I believe we are done with the packet, except for if you could look at the stamp sheet side very quickly. Oh, actually, don't put the packet away. I'm gonna attempt to start one of the quad formula quiz review problems at the end, just if I have time. This is today's. We are doing 111, 114, 116 notes on infinite geometric series, which I believe is actually 116. Homework is 23, 24, 30, and 33. And mental preparation. Tomorrow we're going to do a task practice test. And it doesn't matter what grade you're in, we're all going to do it. Because next week you're either going to take the task practice test or the CASP, or you're going to take the NWEA. So it's good for either one. Tomorrow's is all like in your groups and casual. So you're gonna have a performance task that you're just gonna do on paper. And then you have a practice online task test. You're gonna actually log in with your Chromebook and do it, but you're gonna do it in your groups, like relaxed style. It's more about figuring out the tools and dragging stuff and how the questions work and things like that. So that's what we're doing tomorrow, and then the homework then will be a review worksheet. After today, you will have learned everything you need for that, so you could start it early if you wanted to. Okay. Anyway, next I want to note this thing in bold here. We have a quiz on Friday. Just want you to know. I will look at the topics posted at the end. Just want to mention quiz on Friday. Friday quiz. Friday. On that quiz, 3 formulas will be posted at the top. The arithmetic sum formula, the geometric sum formula, and the quadratic formula. All 3 of those will be in boxes at the top of the quiz. You do not need to memorize those, and you are allowed calculators. Okay? Okay, now just scooch this over to the side. Grab your notebook. And go ahead and set up this bit. Also, none of the things I said were April Fool's jokes. Those are all real things I said. I'm not fooling anyone. I do have something funny that happened to me this morning though. I was listening to Spotify on the way to work, which I listen to pretty much every day on the way to work. And I like to listen to the DJ guy, except for that he plays the same 10 talk. You guys know what I'm talking about? Yeah. The AI DJ guy. Did anyone listen to him this morning? So, I've been trying to explore listening to different styles of music and different playlists because he gets into playing the same 10 songs over and over again, and it's really annoying. Anyway, this morning I was like, I'm gonna try it out because I listened to a bunch of like random stuff yesterday and like see if he expands himself at all. And then the first thing he says is, hold on guys, I gotta use the bathroom. And then he puts on like elevator music, raps for like 2 minutes. And then he comes back and he's like, I'm just kidding, I'm not real, April Fool's. And then it's fine. And I was like, oh, it's April Fool's. Y'all have to be on the lookout for pranks. Yeah. Yeah. The Talbot children, both of them, they love pranks, love them. I'm not a huge fan. Probably because my children love them. And by children, I mean 23 and 21-year-olds. There's really no age limit on pranking, though, apparently. Oh, Michaela, I'm going to try that while you're doing this. Oh, the calculator thing. It's 2 times, no, 3 times -2 to the 10.
Oh, yeah, so no.
Okay, I clearly don't know what numbers it is. I did it all wrong. I got it. Oh. Okay, guys, let's go. So, um, today we're going to talk about a concept that's difficult for people to wrap their brains around, and that's the concept of infinity. So, today we're going to talk about infinity. Your brain can't handle the concept of infinity. No one can, not even Gauss. So, it's fine. We all have that limitation. It's fine. Imagine lying on the ground and tossing a ball straight up 10 meters. First of all, that's really, really far, farther than it seems. When the ball gets back to you, how far has it traveled? 20. Okay, what I'd like to do is draw a little picture of it on this line. I made this line on purpose. Okay, so bounce up 10, down 10. And then I made a little visual representation there. B, instead of catching it, imagine that you let it bounce. The ball has a bounce ratio of 60%, meaning that each time it bounces, the ball will bounce to 60% of its previous height. When the ball comes back down to you the second time, how far has it vertically traveled in total? Okay, almost. So, yes. So it bounces up again, and 60% of 10 is 6. So it goes up 10, down 10, up 6, down 6. C. Imagine that you let the ball bounce 15 times. Write a geometric series to represent the total vertical distance the ball travels until it comes back to you the 15th time. We're going to draw this. We're going to write the series in summation notation. We're not going to write it out because, well, lots of reasons. We need to practice. We're also lazy. La, la, la. Okay. So, draw my summation notation. And what I'm going to do is I'm going to go, okay, this would be 10 plus 6 plus dot, dot, dot. Uh-oh. There's bad things happening. Do you know what it is? My pen is dying. That's what it is. Please hold. You didn't know what that was? Don't you worry. Don't worry. We have lots. Okay. Okay, so now I'm gonna treat this as 10 plus 6 plus whatever value 3.6, I think. But we're gonna make it fancy. So what would be the first term in this would be 10. And what would be the multiplier? 0.6. And then I'm going to make sure to put n minus 1 here because I wrote it in terms of the first term. I'm going to say that I'm starting at 1 and it said 15 bounces. So I'm going to stop it at 15. However, this is a fun fact and new for you. You can actually multiply a series by a number. Why am I multiplying it by 2? Yeah, because I'm accounting for up and down. So we want to think of it like that. Okay, and now we're going to find the sum using the formula. So I want to remind you of what the formula is, even though I told you that you don't have to memorize it. I feel like the more times you write it, the more chance you do have. Okay, ignoring the 2 for a moment, what's the first term? 10. Multiplier is 0.6. 15 terms. Minus 10. Okay, you know what I'm going to say next? Everyone in the room, make yourself do the calculator bit because it's muscle memory, which is real. Again, I don't do this in one fell swoop. You could do it in one fell swoop. If you felt like doing it in one fell swoop, you could do it with the fraction menu or just gratuitous use of parentheses. And then we can't forget to multiply it by 2 because we have to account for it going up and down. So if we let it bounce 15 times, it would go a total distance of 49.976 meters. Okay, remember yesterday how I said that one problem we did, which I believe was E, the answer was 9.998, and I said it was dangerous if it goes to 10, and I was gonna come back to that today. Okay, this one is dangerously close to what?
25. Oh,
Final answer, 50. Okay, and what this means is bend your mind around this. This is hard. You're not gonna be able to do it. Just give it a go. No one can do it. Not even the geniuses of the geniuses. If I let this ball bounce to infinity, taking away all of the laws of physics, the friction and things like that, so just imagining that the ball bounced to infinity, it would bounce a total of 50 meters. Why? Because each of these numbers is getting tiny as it goes on. And it's going to add these little baby decimals on. And if you imagine the little baby decimals adding all the way to infinity, it would be perfectly good. So that one yesterday with the fracciones, remember him? The 10 over 4,096 guy? That guy, if you kept that series going forever, it would add to 10. Now you can't imagine it. We can't. We just don't have the capabilities in our brains yet. Someday maybe they'll implant some kind of infinity AI chip in all of us. But for now, we just have to imagine and kind of trust what that would be like. There is a vocab word for that. It's called convergence. It converges on a number. Okay. . All right, now, did you guys already write this part up here? Okay, go ahead. You can set all the rest of this up. This is the rest of it. Okay, so I've given you two different series here. They are very different. Um, oh, you're all right. Oh, sorry, I thought your hand was up. Thank you. I thought I wrote something wrong, which is quite possible. But anyway, what we're gonna do is see what the sum is when we have 10 terms and 30 terms, and we're gonna see if the sums are getting dangerously close to the sum number. Okay, so the goal here is to see if we get that like super close rounding business like we did before. Okay, so in this one, this whole problem's calculator, by the way. So sum equals first term times r to the n. Do you guys see where I got r from? I just stole it from here. You can also see it because it's going down, but you can also really just easily steal it from there. Minus first term. Well, I'm going to type it in my cheating calculator too, so 1/2 minus 1. All right, you guys, type that in, see what you get. My biggest problem is that I don't arrow out of the exponent. It's a real problem. Okay, do you think with your common sense that this is dangerously close to something? Can you see that it's dangerously close to something? Okay, so let's do it again. And in this case, change your n to 30 and you can, I don't know about you guys, but this is how lazy I am. I will scroll up in the calculator and hit enter, and I'm just going to change this 1 to a 3. Hmm. Okay, Are you dangerously close to something? Okay, so with everything that I explained, what do you imagine would be the sum if I ran that to infinity? 400. Okay, and that's true. So it converges on 400, which is the proper vocab, which we won't really use in here. That's more of calculus vocab. Okay, now we're going to try again, but we're going to do this one, and we're going to go back to 10 terms. Need more research. Too small of a sample size. I don't really feel like this is dangerously close to anything, do you? Maybe. That's why I said we need more research. Now we're going to try and see what happens with 30 terms. Yikes. Okay, is this, to use a calculus word or pre-calculus word, approaching a number? This one is clearly approaching 400. Is this one approaching something? No, it's just blowing up. It's huge. Okay, now, what is the difference between these two series? There's a very big difference between the two series. Notice what's happening to the numbers. Yes, one is getting smaller as it goes, one is getting bigger as it goes. And we don't really say that. I mean, that's true. And that's the easiest way to tell. But what we say, because we're fancy, is we say the multiplier is less than one and the multiplier is greater than one. Okay, so come down here. These are the same problem, believe it or not. Oh man, Mrs. Tabi, you must have gotten lazy because just pick the same problems as before. Okay, so what you do when you have an infinite geometric series, first, how can you tell? Well, you can tell because there's dots at the end and there's no end. Yeah, yes, hold on. Just give me a second. Okay, so you do a test. You say, okay, what is R? R in this case is 1/2. Hold on, I just wrote that wrong. 1/2 is less than 1, so a sum exists. This means that you can actually do the problem. Now, the best part about infinite geometric series is that this formula for them is so easy. You don't have to do this. You can do this, put a really big number in for n and take a guess, but the actual formula is sum equals first term over 1 minus r. I would derive it for you, but I don't have time. Okay, so on this one, sum equals first term is 200, 1 minus 1/2. Now, I'm going to be honest with you. I'm going to expect to have you show all your work on a problem like this, meaning manipulate the fractions properly. So we're going to do this problem correctly, so that you can see the steps. The first thing I'm going to do is make this 200 2/2 minus 1/2. If you feel like this is a little bit Pythagorean identity-ish, then you're kind of right because you're getting a common denominator. Okay, now what would the bottom be? What's 2/2 minus 1/2? 1/2. Okay, which I'm going to keep, change, flip. Okay, now this should not be shocking to you because we got 400 up here. Yeah. Okay, last thing we're going to do for this one is we're going to write it in summation notation. So what would the equation of this be? So first term is 200 multiplier n minus 1. And this is the best part. Start it at 1, finish at infinity. Okay, now this guy, r equals 24 over 16, which is 3 over 2. And we know that because we also cheated off the previous problem, which told us that it was 3 over 2. 1/2 is greater than 1. So no sum exists. Final answer is infinity. 3 over 2. 3 over 2. 1 over 2 is not greater than. At least I put the greater than symbol correct. This is like, remember back in the day when you were in like math 1 and you had like the square root of -24 and you're just like, no solution. Before the day when you realized about I and like breaking the twins out of jail and stuff, and you're just like, ha, can't square root a negative, baby. I'm moving on to the next problem. That's what you get to do here because there's no solution. But I'm not ever going to be like, there is a solution. It's just infinity. I'm not going to like drop the bomb on you in calculus and be like, oh, no, I was kidding that whole time. No, really, it's just infinity. There's no summation notation. There's nothing. It's just no solution. You move on. It's actually not no solution's the wrong thing. It's infinite. But it's also not infinite solutions. There's just one solution and it is infinity. But there's no sum. Okay. Now we have 8 minutes. Would you like me to do one of the number 12 through 14 on the quiz review? No? No? Yes. I think 12 is actually the hardest one, so I feel like if you're gonna feel like you can't do it, it's because of 12. And maybe I could just get it going to the quad formula part. So tune me out, work on your homework if you don't want to hear this, but Okay, now for this problem and for all of these problems, I find it helpful to list out the series. So over here, I'm just going to say, okay, my first term is 40. My second term is 50, 60, dot, dot, dot. Does that make sense so far? I find it helpful to just list that over here so that it helps me with the visual of this. Okay, so now it says the sum is 600 and is what you're solving for. First term is 40. And the last term, I have to write the equation, but I'm going to write the equation in terms of term 0. So T of n is 10n plus 30. Does that make sense? Are you sure the 10n plus 30 makes sense? Because they're going up by tens and then term 0 would be 30. Okay, so now I didn't show all my work just for space saving purposes, but does it make sense? So I times both sides by 2, distributed and got the 1200 over the other side. Now quad formula. By the way, because I'm lazy, I would change this to be, and I might diamond and box that. I might consider. But you can go straight to quad formula with the 10, 70, and 1200 also. It doesn't matter. Okay, you got the quad formula from there? Just the setup part, yeah. And then on this one, I really like this one because they give you the formula there. So you just put that in for T of n and then just plug in 1 to get the first term. I hope that's helpful.